Section 4.6, Nonlinear Systems of Equations. In this section, we'll see techniques on how to solve nonlinear systems of equations graphically and symbolically. In our first example, we're going to solve graphically the system of equations x squared plus y squared equals 2 and y equals x squared. Now, this is a nonlinear system because, well, at least one of the equations is not a linear equation. We hopefully recognize that x squared plus y squared equals 2. Maybe we recognize this as a circle with center at the origin and radius square root of 2. And hopefully we recognize that y equals x squared is a parabola with the vertex at the origin and opening up. Now, just from this, we might be able to get an understanding of what it looks like, what the system looks like. Let's just draw a very rough sketch. Alright, so if I have a circle centered at the origin with radius the square root of 2, the square root of 2 is about 1.4. So if I draw a circle with a radius about 1.4, I get a graph that looks like this. And then I have y equals x squared. That's a parabola with the vertex at the origin, opening up and maybe getting a couple other points. We know it goes through 1, 1. And 1, negative 1. I'm sorry, negative 1, 1, and 1, 1. So we get a graph that does something like this. And so what we see is there are 2 points of intersection, and we need to find those points. All right, now just from this graph, it's not precise enough for us to say what the solutions are. So I'm going to use the calculator now. But to use the calculator, remember, we have to have our equations in the y equals form. So in particular, we have to work with that first equation, that x squared plus y squared equals 2. And let's solve that for y. Alright, I'll subtract x squared from both sides. So then y squared is equal to 2 minus x squared. Now, to solve for y, I will use the square root property, but remember then, I would have y equals plus or minus square root of 2 minus x squared. So now in the calculator, I have to have both of those to create the graph of this circle. So I'll call my y1 the square root of 2 minus x squared, and I'll call my y2 negative square root of 2 minus x squared. And then I'll also have as my y3 just the plain old x squared, that parabola. Alright, so now going to the calculator, y equals screen, I clear out what I have there, square root of 2 minus x squared, close off the square root, y2 negative square root 2 minus x squared, close it off, y3 is just x squared. And I'm going to graph this in the standard window. So I'll just hit zoom 6 for the standard window, and I get this graph. Now, it doesn't look like a circle on a parabola. Well, I mean, I can see the parabola, but that doesn't look much like a circle. Let's kind of zoom in a little bit on the important information. So let me change my window to, how about negative 3 to 3 on the x-axis and negative 3 to 3 on the y-axis, and regraph it. That looks a little bit more like a circle. Now, it looks kind of flat, though, not what we would expect from a circle, and that's due to our window settings. That's due to the fact that the window is a rectangle, not a square. So one way to overcome this is to hit the zoom key and go to option 5. And what that'll do is it'll adjust the settings so that it appears to be more square. So it adjusted my window, and now I have something that looks more square. Notice how the circle isn't attached. It doesn't really appear to have an x-intercept, but we know it should have x-intercepts. And that's just due to the way the programming is on the calculator. It has issues when we get close to those endpoints in the square roots. Alright, so now I will use the intersection feature of the calculator to find the points of intersection. Now we have to be careful here, because in general, if we were just dealing with two equations, we just hit enter 3 times when we got close to the point of intersection. But now we have to be careful here. So notice up on the left, it's telling me which curve I'm on. I'm on the y1 curve, which was the positive square root. And that's good. I want to get close to this point of intersection. I'm going to hit enter once. Now notice what happens. Notice it brought me down to the second curve, which is the negative square root of 2 minus x squared. But the curve, we don't see any intersections on that lower half of the curve. So now what I need to do is I'm going to press down, and what will happen is it'll now switch to my y3. So really I'm finding the intersection between y1 and y3. I'm near the point of intersection. I hit enter the second time, and as my guess, I'll hit enter the third time. And I do have the intersection at negative 1, 1. Alright, so we have negative 1, 1 as a solution. Alright, now let's go through the process again. Second calc, fifth option. I'm going to move over towards the right-hand side. I'm on y1. Hit enter. Again, it brought me down to y2. Hit down to jump to y3. Get near the point of intersection. Hit enter a second time. And for my guess, hit enter a third time. And the intersection is at 1, 1. So there's 2 points of intersection. There are 2 solutions of this system of equations at negative 1, 1 and positive 1, 1. And we could easily verify those through substitution. So let's just check. I'll just check this first solution, negative 1, 1. Let's substitute that into the original equations. What's negative 1 squared plus 1 squared? Is that equal to 2? Well, negative 1 squared is 1. 1 squared is 1. 1 plus 1 equals 2. And let's check the other equation. Is y1 equal to x negative 1 squared? And that's true as well. Alright, so I only checked the one solution, but I'm confident that both are in fact solutions of the equation, of the system of equations. Alright, second example. Let's solve graphically. Y equals x squared plus 3x minus 10, and y minus 3x plus 9 equals 0. Alright, so our first equation is quadratic, and in fact, if I thought about this, I could rewrite that using some factoring. That factors as x plus 5 by x minus 2. So I know that it has x-intercepts of negative 5 and 2. And I know that it's a parabola and opening up, so I can use that information if I want. Now my second equation, I can rewrite that as y equals 3x minus 9. And so I now have a line with a slope of 3, y-intercept of negative 9. Alright, let's go to the graphing calculator and see what it tells us. Now, I didn't have to use any square roots to solve for y here, so I only need a y1 and a y2. Let's see, x squared plus 3x minus 10, and y equals 3x minus 9. Alright, let me graph those. I'll go back to the standard window. So zoom 6. And I see a parabola, x-intercept at negative 5, x-intercept at positive 2. And I do see a line. Now I can't really see the points of intersection here, so let me adjust my window. So it looks like maybe I should focus in on uh, changing the y minimum. Let's change the y minimum to, how about, negative 15, and let's see if that gives us a better picture. Alright, so I do see both curves. It appears that there's a point of intersection. It appears that there's maybe one or could be 2 points of intersection. So let's zoom in on that area. So zoom in, and I'm going to zoom in on this area. And I do see 2 points of intersection. Let me go ahead and calculate those points of intersection. Calculate the first point of intersection. That's over towards the left here. Now I'm only dealing with y1 and y2. I don't need to move between curves here. So I'll enter 3 times. We have one intersection at negative 1, negative 12. Is there another point of intersection? So calc 5. Let's move to the right. Let's get near where we think that other point of intersection is. Hit enter 3 times. 1, negative 6. Again, let's go ahead and check one of them. I'll check the first one. Is negative 12 equal to negative 1 squared plus 3 times negative 1 minus 10? So that would be 1 minus 3 minus 10. That's negative 2 minus 10. That's negative 12. That checks out. All right, and in the other equation is negative 12 minus 3 by negative 1 plus 9 equal to 0. Let's see, that would be negative 12 plus 3 plus 9. Is that equal to 0? Yes, it is. That checks out. So I'm confident in the solutions, even though I only checked the first one. I'll leave the other one for you to try. Alright, so we've seen how we can solve graphically, but we do have symbolic methods, and really they're the same methods that we learned to use for systems of linear equations. We have substitutions and eliminations. So here we have the system x squared plus y squared equals 9 and y equals negative x plus 3. So I'm going to use a symbolic method here. I'm going to use a substitution. Since I see that I have that second equation already isolated in terms of y, or y in terms of x, I'm going to take this negative x plus 3 and I'm going to use it to replace the y in the other equation, yielding x squared plus negative x plus 3 squared is equal to 9. Now let's remember that negative x plus 3 squared means negative x plus 3 times negative x plus 3. Alright, so if we distribute correctly and simplify that correctly, we'll have x squared plus, and then negative x plus 3 squared would give us an x squared, a minus 6x, and a plus 9. Combining like terms, I have 2x squared minus 6x plus 9 equals 9. Subtracting 9 from both sides to get the right-hand side to 0. And so I'm going to subtract 9 here. 2x squared minus 6x equals 0. Well, now I'll use factoring. 2x by x minus 3 is 0. So then 2x is 0, which implies that x is 0. Or x minus 3 is 0, which implies that x equals 3. So we appear to have two x values, but these are not solutions of the system. These are simply the x values. Now we need to find the corresponding y values. So to find the corresponding y values, we will substitute into one of the equations. And I would just go with the easier equation. We know now that y is equal to negative x plus 3. So if x equals 0, then y would equal opposite of 0 plus 3. Y would equal 3. if x is equal to 3, then y would equal opposite of 3 plus 3. Y would equal 0. So, solutions of the system then, if x is 0, y is 3. 0, 3. If x is 3, y is 0. 3, 0. All right, so the solution, there are two solutions of the system, 0, 3, and 3, 0. Let's see another example where we solve symbolically. We have x squared plus 3y squared is equal to 9, and x squared plus y squared is equal to 6. I'm going to use an elimination method here. So what I'm going to do here is I'm going to try to eliminate, on x. And to do that, I'm going to multiply the second equation by -1. Why am I doing that? That'll give me an x squared in the first equation, a negative x squared in the second equation. That'll provide an elimination on x. So I now have x squared plus 3y squared is 9. I haven't changed the first equation. Negative x squared minus y squared is negative 6. Now I will add the equations together, term-wise, yielding 2y squared is equal to 3. So then y squared is equal to 3 halves. So then y is the positive or negative square root of 3 halves. So now remember, this is two numbers. Y is negative root 3 halves and positive root 3 halves. Alright, so now what I'll do is take one of the equations and solve for x using each of those values of y. Alright, so now, if x squared plus y squared is 6, let's let y equal negative root 3 halves. If y is negative root 3 halves, then x squared plus negative root 3 halves squared is 6. X squared plus, well, negative times a negative is a positive, and root 3 halves squared is 3 halves. Subtracting 3 halves from both sides, remembering that 6 is the same as 12 over 2. Then x squared is 12 over 2 minus 3 over 2, 9 halves. And so then x would be the positive or negative square root of 9 halves. So this gives us two solutions. Negative root 9 halves, comma, negative root 3 halves, and positive root 9 halves, negative root 3 halves. So there's two solutions. Similarly, if y is the positive square root of 3 halves, we end up following the same process, and we would find that x is equal to positive or negative root 9 halves. And so we get two more solutions. Negative root 9 halves, negative root 3 halves. I'm sorry, that should have been a positive there on the 3 halves. And negative root 9 halves. Sorry, that one should be a positive. Positive root 3 halves. So we get 4 solutions of this system. And we could simplify these and put them in different forms, but that's the main idea. Let's consider the system x squared plus y squared is 16 and x squared plus y squared is 25. What if we tried to use an elimination again? I'll multiply the second equation by -1, yielding x squared plus y squared is 16. Negative x squared minus y squared is negative 25. Adding the equations together term-wise, the left-hand side, x squared minus x squared is 0, y squared minus y squared is 0, so the left-hand side becomes 0, and the right-hand side, 16 minus 25, is negative 9. Is 0 equal to negative 9? And so this is a contradiction. And what this tells us is the system has no solutions. And you might have been able to determine that from the very beginning just by thinking graphically. If we think graphically, x squared plus y squared equals 16 is a circle centered on the origin with a radius of 4. X squared plus y squared equals 25 is a circle centered on the origin with a radius of 5. Now, even though those are very poorly drawn circles, they don't intersect. They will never intersect, and so graphically we can see that the system has no solution. And we saw the same thing symbolically trying to use an elimination. All right, that concludes the presentation for this section.